Hello, this is Professor C.P. Prakasham, former professor from International Institute for Population Sciences, Mumbai. I will be discussing about Levene's test to test the homogeneity of variance of the distribution. Here you can see that the two distributions with mean and difference variance, V1 and V2 are the variables which are given here, and you can see here some of the observations is same, mean is same, and variance is different, and as well as the standard deviation is different. Here you can see right side the distribution, the variance is there, because to find out the variation between the distribution, a significant difference between the means of the two samples can be judged either by the statistics because of the small samples, or because of a z-test on the basis of the sample size criteria. To evaluate three or more means, analysis of variance is used. Therefore, both these tests requires one strong assumption that homogeneity of variance assumptions is required. That is, the population variance of the dependent variable must be equal to within all groups. For testing with this purpose, Levene's test is used for the homogeneity of the assumptions. What is the Levene's test? Levene's test is used for testing the homogeneity of the variance. Levene's test is used to check that k samples have approximately equal variance or not. With this purpose, then if it is not equal, then analysis of variance is used. Then Levene's test is defined as H0 equals to variance of one set of sample is equal to variance of another set of sample, and so on up to k variance. But H1 is that that is variance of 1 is not equals to variance of 2 is not equals to, like that it is. That is, H0 is the group variance, all group variances are equal. H1 is the group variance, at least any two of the group variance are not equal. To test this, Levene's test is used in the analysis of variance, one-way or two-way analysis of variance, with an assumption that equal variance between the groups. But basically, it requires two assumptions before testing. One is that independent observations and test variable is quantitative, that it is not nominal or ordinary. Then what is the formula for Levene's test? Given a variable y or x or v1, whatever be, with a sample size n divided into k subgroups, where ni is the sample size of ith group, then the Levene's test formula w equals to n minus k, that is n is the total sample size and k is the subgroup sample, and then multiplied with the summation of ni with the difference of zi, that is group mean minus total mean whole square, divided by the double summation of zi, that is the individual observations in the cell, minus zi bar star whole square. Here most of the values n, k and zi and z double dot are derived from the observations. Then only the variation is occurred with the z, which is the distribution. Therefore, this will be again modified by the Levenes, that where zi equals to if yij minus yi dot, this is the mean of the observations, yi is the variable, then when the mean of the subgroups, it is subtracting with the mean of the subgroup and then calculating it, modulus of that. If the distribution is not having the median, then it will take into consideration of the median of the subgroups, and if the distribution is having trimmed mean also, it can be calculated. Therefore, Levene's test will take into distribution pattern also while calculating the formula for that W. Then what is the decision one has to make? If the non-significant results of Levene's test is that if it is greater than the 0.05, that is if the probability values is larger than the alpha value, indicates that the assumption of homogeneity of variancy is met. Equal variancy is assumed and accept H naught. If the significance is less than 0.05, that is if the p-value is less than the alpha level, indicates that the assumption of homogeneity of variancy is not met. That is equal variancy is not assumed. Then reject H naught. If this is done, if the H naught is rejected, then the analysis of variancy will be carried further. Otherwise, it is not required for carrying out for the analysis of variancy. This is the here the researcher is interested to find out the variation between the total number of children ever born, that is fertility index, and as well as the religion wise. Then for that purpose, we have to find out the variation, significant variation or not, by using the Levene's test. Go to the analyze, click, and then go to the comparison means and proportion, and then get one-way analysis of variancy. Click here. Once you click here, total number of children, you bring it to the dependent variable, and then factors for that is the religion. Then you can find out the options for that. You can find out the options, click options. Once you click option, then you can click descriptive statistics, which will give the mean, standard deviation and other things, and a homogeneity of variance test by using the Levene's test. Then click here, say continue. Once you say continue, then say OK, then you will get the output here. In this output, you can see that first of all, descriptive statistics. Descriptive statistics very clearly shows that the mean, standard deviation, standard error, and other things also. Here you find mean is according to that, it shows that, and the variance is very different here. For testing for homogeneity, then we are applying the Levene's test. Earlier we have already given that Levene's test is will be calculated on the basis of the distributions mean as well as the median as well as the trimmed mean also it is given. And it shows that Levene's test, whether it is a significant or not. Once it shows that significant, that shows that there is a significant variation is existing. For that purpose, then we will reject the null hypothesis and accept that there is a variation in the significant variation, and the observations are homogeneity test is required. For that purpose, we will further calculate analysis of variancy and see whether there is a variation exists or not. That will be given by the F ratio test, and it is also shows the significance level between the group as well as within the group. Therefore, the Levene's test is used to find out homogeneity of variancy. If it is not significant, that means there is no variation, and then it has been. Levene's test is a most powerful test because for a symmetric and moderate tailed distribution, if there is a skewness is there in the distribution and large kurtosis is also existing, then Levene's test is not that much powerful, because when you see the observations Zij, each is calculated on the basis of the mean, median, and then as well as the trimmed mean of the observations, but not on the variations of the skewness and kurtosis which are existing and deviate from the normality. Then Levene's test along with Brown-Forstey test are more robust against the violation of the normality assumptions. But when compared to the F test, Levene's and Brownish-Forstey test is the more powerful. For reference purpose, one can see that Brown MB, Forstey 1974 robot test for the equality of variancy, which is available in the Journal of American Statistics Association. Thank you very much. Please like it, share it, subscribe it, or place your comment by through the email. Thank you.